Hello, wonderful people. It's Medicosis Perfectionalis, where medicine makes perfect sense. After the success of my biology playlist and biochemistry playlist, it's time to talk about chemistry. If you're tired of your professor's mumbo jumbo and want something clear, short, and precise, you want to get in, get out, then this series is for you. It's Medicosis General Chemistry Quick Review playlist. Let's get started. When I talked about metabolism in biochemistry, we had the 10 commandments of metabolism. Today, we have the 10 commandments of chemistry. Commandment number 1. Thou shalt understand how to read graphs, the x-axis, the y-axis, etc. Thou shalt tell the difference between directly related and inversely related entities. Number 3. Learn how to tackle chemistry problems or questions with a medicosis methodology. And of course, you need to understand the concept of entropy. Think of it as disorder. Next, numerical value versus the measuring unit. What are the types of matter, and what the 7 standard international base units of matter are, and the difference between fundamental quantities, these 7, and derived quantities. Changes in matter, types of energy. See, it's all about matter and energy. And we'll conclude by implications of periodic table plus questions. To get the most out of this playlist, do not watch these videos while sleeping on the couch. Instead, I want you sitting at your desk, upright, with a pen and paper in hand. How about an iPad and Apple Pencil? No. Why don't you like the iPad? I love the iPad. It helped me make more than 1,800 videos on this channel. However, for understanding, for speed, for less distractions, there is nothing like pen and paper. Also, whatever you're writing down on these papers, do not throw them away, because they'll help you tremendously in general chemistry, organic chemistry, biochemistry. So keep them in a safe place. Next, anytime we encounter a question in this series, please pause the video and try to answer this question yourself before I tell you the answer. And not just pen and paper, you will need to bring a brand new mistakes notebook, also known as boo-boo notebook or oopsies. And anytime you make a mistake in one of these questions, write the concept that you learned in the oopsie notebook. Your boo-boo notebook plus my handwritten notes will make you invincible in chemistry. Please save this playlist called General Chemistry Review and watch these videos in order every single day. You have no idea how much you can accomplish in a short period of time. Do not wait until YouTube recommend my videos to you, because when you're browsing YouTube before bed, you're not in mood to study chemistry, obviously, so you'll skip my videos 2 or 3 days in a row, so YouTube will say, aha, you're not interested in chemistry anymore, and will stop recommending my videos. You need to actually save the playlist and actively come every day. Intentionality, people. At the end of this playlist, there will be an ultimate chemistry review, one humongous video reviewing all of chemistry, and will be tons of questions. These videos go hand in hand with my chemistry notes, which you can download on my website, medicosisperfectionalis.com. 10 commandments of chemistry. Number 1, how to read graphs. The first step in reading a graph is to look at the horizontal axis and the y-axis. Oh, we have time here. We have concentration here, or any other entity. Next, what if I told you that this is volume and this is mass? What do you think the slope of this line is? It's mass over volume, rise over run, and mass over volume is density. So the slope of that graph will represent density, because density is mass over volume, rise over run. This slope also equals tan of theta angle. The angle theta is between, pay attention, the slope, this diagonal line right here, and the x-axis. So it's between the diagonal and the horizontal line. It's here, not here. If you put it here, you will ruin everything. The theta is here. It's how much did I rise above the run. So do you see this lovely line right here? Let's call it x. And then let me draw another line right here and call it y. Between x and y, which one has higher density? Well, whoever has the highest slope. And which one has the biggest slope? Whatever has the biggest theta angle. So y has a higher slope, which means y has a higher density, assuming that mass is on the y-axis and volume is on the x-axis. So first step, you look at the axes and then you look at the relationship. If we're going this way, it's directly related, which means as the volume goes up, the mass goes up. But what if it was the other way around? If as volume goes up, mass goes down, then the graph will look like this. Oh, you see the difference between this and this. Going up, going down. Let's play with some numbers. Suppose that this theta angle right here is 45 degrees. What's the slope? Well, tan of 45 equals 1. Positive 1, that is. How about here? Where is the angle theta? Oh, medico says it's this one, 90 degrees. Shut up. Oh, then it has to be this one, between this line and the horizontal, which is about 45. Also shut up. Because if this is the theta, then tan of the theta equals positive 1. Well, how come this is positive 1 and this is positive 1, even though this is directly proportional and this is inversely related? It cannot happen. It's impossible, c'est impossible. Theta is here, my friend. It's the angle between this line and the horizontal axis. It's how much did I rise over the run. Oh, look at all of this. So let's say it was 135 degrees. What is tan of 135? Answer, -1. Because these things are directly correlated, you get a positive. It's a positive correlation. But these two entities, x and y, are negatively correlated, inversely proportional. So you get a -1. See, it makes perfect sense once you understand what the flip you're talking about. And there is another way to get the slope. It's the rise over the run. The change in the rise over the change in the run. So let's just imagine some numbers. Imagine that this point is 1 and this point is 2. And then imagine that this point represents 3 and this is 2. What's the change in the rise? 2 minus 1 is 1 over the change in the run. 3 minus 2 is also 1. 1 over 1 is 1. Positive 1, that is. Let's play the same game over here. This is 2 and this is 1. And here we have 2 and 3. And then you have the change in the y. So it's y2 minus y1 over x2 minus x1. Where is y2? Here. It's the 1, not the 2. And where's y1? It's here. So it's 1 minus 2 over 3 minus 2 equals -1 over 1 equals -1. That's the slope of this graph right here. Another fundamental question. What's the difference between this line right here and something that looks like this? Well, easy. The straight line is a linear relationship. They are directly related in an arithmetic manner. But look at this nonlinearity. Nonlinear relationship or geometrical or exponential, etc. The same thing could be told of the inverse. I can draw a line, or if it's nonlinear, I can draw something like this. Chemistry commandment number 2. How can we read such a thing? Well, A and B are directly related to each other. Numerator, numerator with equal in between. How about between A and C? A and C are inversely related to one another, assuming that B remains constant. Now suppose that A remains constant. What's the relationship between B and C? Meaning if C increases and A stays the same, what's going to happen to B? Answer, B will also go up. How come? When two entities are divisible by each other, they are directly related to each other. If two entities are divisible by one another, then they are directly related, provided that the third entity stays constant. And that's why A and B are directly related when C remains constant. Because A and B are divisible by each other. How come? I can put B down here. So it becometh A over B. And then what was under here is 1 over C. So I can put it this way. A over B equals 1 over C. And when you draw it this way, now A and B are divisible by one another. If two entities are divisible by one another, they are directly correlated with one another. As A goes up, B goes up, provided that C remains constant. But what if two entities are multiplied by one another, like A and C here? Because I can rearrange this to become A times C equals 1 times B. You can ignore the 1. If two entities are multiplied by one another, then they are inversely related to one another. So, by keeping B constant, as A goes up, C goes down. As A goes down, C goes up. How about an equation like this? This is addition and subtraction instead of multiplication and division. When two entities are added to one another, they are inversely related. But when they are subtractable from one another, they are directly related. Can I make A minus C? Sure. You can bring C here with a negative sign, so it becomes A minus C equals negative B. A minus C. Oh, subtractable from one another. Directly related. How about B and C? Are they subtractable from one another? Absolutely. I can bring the B here. It becomes C minus B. Oh, C minus B. Subtractable from one another. Then they are directly related. So the moral of the story is, if two entities are divisible by one another, they are directly related. Or if two entities are subtractable from one another, still directly proportional. But if you can multiply them together or add them together, then they are inversely proportional to one another. And this is very important to understand chemistry equations, physics equations, biochemistry equations, physiology equations, all kinds of equations. So we're done with 1 and 2. Let's go to number 3. How to tackle chemistry problems on your exam. Here's the deal. If the question stem is long, you should read the last sentence first. And the last sentence could be, what's the density? Oh, now you'll go up and continue reading the entire thing. But now your mind is focused. Oh, I'm looking for mass, I'm looking for volume so that I can get the density. So get the mass, get the volume faster than if you have read the whole thing from top to bottom, because by the time you end up here, oh, density is what? Like mass over volume. So let me go up again and find the mass and the volume. You will waste a lot of time doing this. Read the last sentence first. Okay, what's the density? You had the mass, you had the volume, you divided the mass by the volume, and you got your density. Try to write down the correct answer before you look at the choices. The answer choices are not your friends, they are your enemies. They are there to use you and confuse you. So you get your answer first. Oh, I know the density is going to be 2 kilograms per liter. After this, you can look at the choices until you find the 2 kilograms per liter, and then you pick that one. Here is another thing that can happen. Some people say we'll find 2 here, and then they will stop reading the rest of the choices and, oh, A is the correct answer, I'm sure. No, you need to read all the choices, because sometimes A is 2, but it was 2 grams per liter instead of kilograms per liter, which was written here. You have to read all of the choices before you pick an answer. Another important tip, write down all the knowns. If here they told you that the mass was 4 kilograms, and then you write down M equals 4 kilograms. And here they told you that the volume was 2 liters. Write down that V equals 2 liters. Write down the equation, density equals mass over volume, M over V. 4 over 2 equals 2 kilograms per liter. You need to have a system to tackle these problems. Otherwise, the professor is going to run circles around you. After you chose the correct answer, double check your answer. And here's the thing. Please listen carefully. Do not change your answer. Do not change your answer. Do not change your answer. No exceptions. There's only one tiny exception. If you have an aha moment, if the question said all of the following statements are true except, and then you did not read except the first time. So you chose your answer based on the fact that there was no except. Now that you discover there is except at the end of the sentence, you're now allowed to change your answer because that's a major aha moment. But if it's just doubting yourself, no, stick with the old answer. Stick with the first answer that you chose. Most cases, it's the correct one. Hey medicosis, what if I have no idea which of these is more likely to be true? Like, I'm clueless. Then pick anyone. Do not leave it empty. You can even pick your favorite letter. I don't care. Do not leave it empty. Next, entropy, disorder, randomness, freedom. Here's the thing about nature. Nature loves going downhill. This is tweetable right there. Memorize this. Nature loves to go downhill from high energy states into lower energy states. Get that snowball rolling. When you observe snowballs rolling, are they rolling downhill or uphill? I'm talking spontaneously, without anyone pushing them. Oh, they will roll downhill. That's exactly the point. Nature goes from high energy to low energy and from more order, like this, to less order, like this. Get a cube of ice, leave it at room temperature, and see what's going to happen. It will change from solid, which is well organized like this, into water, liquid water, which is less organized. I went from more order to less order. Do you think if you leave the ice at the room temperature long enough, the water can turn back into ice? Never, because nature only goes downstairs. But hey, medicosis, I can put it in the freezer. No, that's different. That's not spontaneous anymore. Now you are actively adding energy to the water to make it back into ice. That's different. We're not talking about that. We're talking about naturally, spontaneously, without any intervention, without adding any energy from outside. You're always going to go from high energy to low energy, from more order to less order, i.e., from less disorder into more disorder. Because if something has less order, it has more disorder. And what's the word that is synonymous with disorder? Entropy. So nature loves to go from low entropy to high entropy. If an organized, arranged deck of cards fall off the balcony, it will go from more order, organized deck, into less order, disorganized deck. No matter how long you wait, it's not gonna reshuffle itself back to an orderly order again. It's not gonna happen. Now, these are the basics. When you go to theoretical physics later, they will tell you it's not 100%, it's just that it's way more likely this way than the other way. Okay, who cares? Extremely unlikely and impossible are not that different from a practical standpoint. So we go from less disorder into more disorder. That's why scientists predict that eventually the sun will run out of light. All life forms that we know will perish as the universe increases in entropy. Next, numerical values and measuring units. If I say 250.21 meters, the 250.21 is the numerical value and the meter is the measuring unit. Let's talk about matter and energy, starting with matter. Types of matter. Matter could be pure or could be a mixture. Energy could be potential energy or kinetic energy. Let's start with matter. Pure or mixture? What do you mean by pure? I mean it's easy to separate them physically, relatively speaking. And if you just have one type of atom, we call you an element. If you have two or more types of atoms, we call you a compound. Example, when I say oxygen, oh, that's an element, one type of atom, it's just oxygen. How about water? Oh, that's a compound because here I have two types of atoms. I have hydrogen atoms and an oxygen atom. If the matter is not pure, it is a mixture, meaning cannot be easily separated. And we have two types, homogeneous mixtures, which are identical in composition throughout, or heterogeneous mixtures. Can you give me an example of homogeneous mixture? Sure. How about adding some salt to water, stirring the salt until it disappears, until we have a salt solution? Oh, that's homogeneous. When you look at that water, it has the same composition. Whether you're looking up the glass, down the glass, in the middle of the glass, doesn't matter. But let's add oil to water. Oh, that's heterogeneous. Oil will remain on top, water at the bottom with a layer in between. Heterogeneous, not identical composition throughout. Next, we'll talk about the 7 standard international base units of matter. And there you go. We have length, time, temperature, mass, amount of substance, electric current, light intensity. How do you measure length? The measuring unit is meter. How about time? In seconds. Temperature? In kelvins. Mass? Kilograms. Amount of substance? Mole. Electric current? Ampere. Light intensity? Candela. Note, lowercase m, meter, for length, but uppercase m means mole, for the amount of substance. One has nothing to do with the other. So we have to pay close attention. Moreover, candela, abbreviated lowercase c, lowercase d. What if it was uppercase c, lowercase d? That's cadmium, an element of the periodic table. Has nothing to do with the candela. So pay attention to how they are written. Why do we call these SI base units? Système International. It's a French term. If we take two of these fundamental quantities, we can derive a derived quantity from them. For example, you look at this, meters, okay, over time in seconds, what do you call that? Speed. Is speed one of these? No. Is it derived from some of these? Yes. So speed here is that derived quantity, while distance and time are fundamental quantities. After talking about types of matter, let's talk about changes in matter. Physical changes, chemical changes, nuclear changes. Physical changes are involved with small amount of energy. Chemical, usually larger. Nuclear, a humongous amount of energy. As ice melts, that's a physical change. Burning wood is a chemical change, more energy. A nuclear reactor can release tons of energy, and we can use that energy to generate an electrical current. Next, let's talk energy. We have two big categories of energy, potential energy and kinetic energy. Potential means stored energy. Kinetic, kinesis, movement, energy in motion. Potential energy includes chemical energy, nuclear energy, gravitational energy, elastic energy. How about kinetic energy? Motion, mechanical. Oh, I'm moving. Electrical. Electrons are moving. Thermal, heat energy is being transferred from the hot to the cold object. Radiant, oh, radioactive. Active, in motion. Last, some implications of understanding the periodic table. Instead of just memorizing everything like a freaking donkey, let me actually explain to you why this is vital. I'll just give you 5 facts. Many patients have high blood pressure. Doctors will say, eat less salt. Decrease your sodium intake. Some of these patients go to the store and they will find sodium alternatives. Guess what these sodium alternatives are made of? Potassium. Why is that? Because it belongeth to the same group or column in the periodic table. So potassium can replace sodium in the food. Fact number 2. Some doctors will recommend that these patients with high blood pressure lower their sodium intake and raise their potassium intake, fruits and vegetables, and less of these spicy noodles. Fact number 3. The last part of your kidney is known as the distal collecting duct. After this, we have the collecting ducts. These collecting ducts tend to reabsorb sodium but excrete potassium. Bring that sodium back to the system, but then get rid of the potassium. Why do they do that? Because sodium and potassium compete with one another. Why? They belong to the same group in the periodic table. The same part of your kidney can also reabsorb sodium and excrete hydrogen. Oh, how come? They belong to the same group in the periodic table. Next, cadmium poisoning, mercury poisoning can replace zinc in your RNA polymerase, which means no transcription for you, which means no protein synthesis. That's why cadmium poisoning and mercury poisoning are not good for you. It's all here, baby, in the periodic table. Fact number 5. Strontium from radioactive fallout can be dangerous for you. Why? Because strontium and calcium belong to the same group in the periodic table, meaning strontium can kick the calcium out of your bones. Bones without calcium are weak, increasing your risk of fractures. So after all of this, I do not want to hear, oh, I have no idea why we're studying chemistry. Oh my goodness, chemistry is so beautiful. Chemistry is life. I just told you about 5 vital facts from the periodic table. If you want more, check out my video titled Minerals. You'll find that in my biochemistry playlist. And there you go, the 10 commandments of basic chemistry. And before we go, here are 2 questions for you. Question 1, if A plus B equals C, we'll keep C constant. A will go up. What's going to happen to B? Is it going to go up, down, no change, or it depends? Second question, We have three graphs here, A, B, and C. Which one of them has the highest compliance? Knowing that compliance is the change in volume over change in pressure. But I've not studied compliance before. That's the point. You can answer this question without knowing what the flip compliance is. It's all about concepts. Do you understand the concept? Do you know how to read a graph? Please let me know the answers to these questions in the comment section. You'll find the answer key in the next video when we talk significant figures and scientific notation. I've talked a lot about the distal convoluted tubule and the collecting duct of your kidneys. Do you want to learn more about filtration, reabsorption, secretion, titratable acidity of the kidney, the counter-current multiplier, and much more? Then download my renal physiology course at medicosisperfectionalis.com. Thank you for watching. Please click the join button, choose the highest tier to gain access to more than 300 premium videos right now. Subscribe, hit the bell, smash like. If you want my notes or if you want me to tutor you, go to medicosisperfectionalis.com. Be safe, stay happy, study hard. This is Medicosis Perfectionalis, where medicine makes perfect sense. Medicine and chemistry.